Welcome back. In the previous two parts of this lesson, we have discussed about a basic of KMap or Karnaugh maps, the rules, and how we can actually group cells within the KMap using the rules that we have been explained before. So in this lesson, I will explain of how we can actually write a Boolean expression out of the grouping that we have created within the KMap cells. From the previous lesson, we know that in order to group cells in KMap, we have to group all the ones and with the largest possible group based on the 2 to the power of n rules. So we can have a group of 1, 2, 4, 8, and so on based on this 2 to the power of n. So based on this one, we have KMap cells with a number of ones input within the cells. So based on these rules, we can group the cells like this. So the first one will be these 4 ones within one group. The second group contains 2 ones, okay, because we don't have any other adjacent cell with one input. And the last one, we need to cover this one. So basically we can take these 2 because we can take the leftmost and rightmost cells and group together. So based on these rules, we have 3 group within these examples. Next, we'll see how we can actually write the Boolean expression for each of these grouping that we have made in this example. Alright, now we have made the grouping of our KMap cells. We want to see how we can actually write the expression for each of these groups. So we will expect that we will have 3 product terms from here, 1, 2, and 3. Okay. Alright, before that, don't be confused about this one. Okay, so if you see, I put both the level using the numbering, which is a binary combination 0, 0, or you can actually write using the variables convention. 0, 0 can be represented by A complement, B complement, and similarly 0, 1 is actually can be represented by A complement and B, and so on and so forth. Alright, so in order for us to determine the expression for this KMap, so we have to follow this one. Eliminate variables that occur both complement and uncomplement. What means by this actually, for A variables, if A and A bar or A complement occur within the group, so we will eliminate these A variables within the expression. If B and B complement has occurred within the group the same time, so we will eliminate this variable, which means in this example A will not appear in our product terms. Alright, let's have a look for our first group here. So for group number 1, if you can see from the grouping here, we will see that A complement B is next to A and B. So in this group, A is occurring both complement and uncomplement, so which means A will be eliminated and only B will remain. Okay, so on the horizontal vertical line, you see we have this group is covering C complement D complement and C complement D. So based on this one, D is occurring both D complement and D uncomplement, which means we will eliminate D and the C complement will remain. So our expression for the first grouping will be B and C complement. Alright, the next grouping. So we have two ones within this group. So if you look at here, the vertical part A, B complement is not changing, so it will maintain. Okay, and from vertical side we have C, D next to C, D complement. So in this grouping, D is occurring both, D and D complement, which is we will eliminate D and C will remain. So the final expression for this group will be A, B and C. Okay, the last one, the last group also contains two ones, 1 and 2, and the grouping covering in the horizontal line is only C, D complement, which means C, D complement is maintained because it's not adjacent to any cell. But for the horizontal line, it is adjacent between A bar, B bar and A, B bar. If you look at here, A is changing from covering both A complement and A. The only things that not changing is B complement. So A will be eliminated and only B complement will maintain. And we end with this lower part, which is C, D complement, and the final expression for this group is B complement, C, D complement. Alright, you may be realized the larger the group, and we'll have a more simplified version of its expression. Like the first group covering 4 ones in one group, the terms will only have 2 input variables, and the second group and the third group only have 2 ones in one group, and it's come out with 3 variables in its expression. Alright, this is how we can write expression from KMap grouping. Next, we'll have another few examples for you to understand in different size of KMap. Alright, let's have a look of another example. This time we have 3 input variables A, B and C, so we can arrange A, B and C within the KMap tables like this, and you can label each of the A, B and C input using whether binary combination, or you can have the variables combination like this. Alright, so from here we know that this KMap has 4 cells with ones, so we have to group these 1 cells in at least one group. So what we can do is we can have the first group here to cover only 2, and the second group we can take the overlap with another one that has been used in previous group. It's okay in KMap. And the last one we still have one which is isolated here, so we have no choice. We can only group this one with only a single ones in a group. Alright, so next, how we can write down the expression for each of these grouping that we have done. Alright, okay, let's look back at this one. So variables that occur both complement and uncomplement will be eliminated. Alright, for the first group, so we have A bar, B bar, A bar, B. So it is obvious that B is occurring both complement and uncomplement, which means B will be eliminated. So the only variable that remains is A complement. On the C input side, C is not changing, only C complement is existing, so we can just straight away maintain, this is a C complement, so C complement is maintained. So the expression for this group will be A complement and C complement. So for the second group, similarly, on the AB side, we have A complement B, which is not changing. So we will maintain both of this one because both variable only occur one. Okay, so A bar B will maintain, but on the C input side, you look at here, C is occurring both. C complement and C, both is occurring, so that's why C is eliminated. So the only variables or final expression will be A complement B. Alright, the last group here, the third terms, will be on the AB side variable. So we have A B complement, which is not changing or is only occurring once, so we will maintain both. So A B complement is maintained, and similarly C input only occurring at C, so C is occurring only a complement, so C will maintain. So we will have a final expression for this one as A B complement and C. Alright, so let's say this output expression is, let's say we give it as F. So F will be A complement C complement, or A complement B, or A B complement and C. So we have these three terms as the final expression for this KMap. This is an example for three input variables KMap. From the previous lesson, we know that in order to group cells in KMap, we have to group all the ones and with the largest possible group based on the 2 to the power of n rules. So we can have a group of 1, 2, 4, 8, and so on based on this 2 to the power of n. So based on this one, we have KMap cells with a number of ones input within the cells. So based on these rules, we can group the cells like this. So the first one will be these 4 ones within one group. The second group with contains 2 ones, okay, because we don't have any other adjacent cell with one input. And the last one, we need to cover this one. So basically we can take these 2, because we can take the leftmost and rightmost cells and group together. So based on these rules, we have 3 group within these examples. Next, we'll see how we can actually write the Boolean expression for each of these grouping that we have made in this example.